it might consider as well the different categories. So you need to collect, for example, from low income, higher income, medium income, so as a combination, for example, rather than just randomly selecting a certain sample. And it can be in a different sequence as well, which we can use it again here in the cross-validation in terms of picking up samples, training and testing. Okay, I'm going to cover here fastly just how we can assess the models. Then we're going to move, I'll move into Tableau fastly to conduct some analytics using Tableau. Then we will move to R. Here, if we have a classification models, basically we assess the model using classification matrix. In a simple way, for example, if we have here the customer name, the customer, yes, have left the company or have not left the company, and here the churn score. And if we are using 0.5% to predict yes, whether the customer will leave the company or no. So based on this, our prediction that the customer is going to leave the company and for the rest is less than 50%, so he's not going to leave the company. However, this is our true predictions, right? So we can say if our prediction is yes, and we predicted yes, this is a true prediction, which we call it a true positive, right? Because it's positive, but it's a true message. Then if our prediction yes, or if it's actually yes, but our prediction is no, this is negative, but it's a false. That's clear? Right. And the same here, if our prediction is no, sorry, our actual is no, but our prediction is yes. This is positive, but it's a false positive. It's a wrong positive. Here, if the same, I mean, here if it's no, this is true negative. So basically here what we are saying, for a classification, we can assess the accuracy using the classification matrix. In regression, we use the mean squared error. I believe all of you know about the classification matrix in assessing the errors, classification errors. Do you know about the classification matrix? Yes? Don't feel shy, just, yeah, if all of you know about it, then that would be great.
I don't think I know.
You don't know about it, okay. Yeah, all right. So the classification matrix, basically, let me present it here in a simple way. So for example, so if you have actual status, that represent, for example, would the customer leave the company or no. So here we call it yes, he actually left the company, or no, he didn't leave the company. And here we have our prediction. Our prediction would be like, yes, the customer is going to leave the company, or no. Like on any classification that have yes or no, 1 or 0. So what is your correct predictions? When the customer, I predicted yes, he's going to leave, and the customer left, right? So this is a correct prediction. And if I predicted no, the customer not going to leave, and he didn't leave, this is also a correct prediction. Right? I call this one a true prediction because it's correct, but it's a true positive because I mean the answer is yes. So I call it true positive. At the will I call this prediction? Is a true prediction, because I mean I predicted no and the answer was no. But the true negative, that's mean these gonna represent the correct predictions, and the rest gonna represent a wrong prediction. So I call this one, I predicted yes, but the customer actually didn't. So this is false positive. It's long positive prediction, so it's false positive. And this one I predicted no, the customer not gonna leave, but actually the customer left. So I call this false negative. It's false because wrong prediction, and our prediction was negative. So it's a wrong negative prediction. So the accuracy, basically, what's your correct predictions? Are the diagonal, right? So the diagonal, your correct prediction, like yes, yes, no, no, over the total. So your correct prediction over the total will represent the accuracy of your model here. So here the accuracy of your model, write it up. So here, the accuracy of your model, let me give you an example. For example, you have 100 case. You have here 45. You have here 35. You have here 10, and you have here 5. So your accuracy would be the correct prediction, the diagonal, like true positive plus true negative over the total, right? So it should be 45 plus 35 over 100, which is basically 85. Or okay, here is 15. Okay, which would be 80%. So in this case, we calculate the accuracy of the model in terms of the classification. Is that clear? Okay, because here we are doing a classification. We have different measurement for the confusion matrix. Not only the classification would be important, but some other measurements, which we call it classification error, sensitivity, specificity, precision, and F measure. Like I'll go fastly through these just to give you an idea of what does it mean. So sometimes it's important to compute this. So I mean, simply, if the accuracy is 80%, what's the error? Classification error would be 20%, which is the rest, right? You're gonna compute the errors, like 5 and 15. This is errors out of 100. So this is the classification error, which you're gonna get the false predictions, right? So here, the error or classification error is basically 5 plus 15 over 100, which is 1 minus the accuracy, simply. I mean, this is the same measurement. We have something called sensitivity. Sensitivity, basically, here we are saying it's the true positive over the true positive and the false negative. So what does that mean? The sensitivity means, okay, considering the actual yes, how many actual yes do we have? Or actually the customer left the company. We have actually like 60 customers left the company, right? 60 customers left the company, yes. How many we predicted correct? Like, yes, he left actually the company. So that's represent the sensitivity, which is the TB. So it's the sensitivity here. Would be basically 45 over 60, right? So the sensitivity is just related to the to the true events, which were actually like the customer left. How many are predicted from these? Just focusing as a conditional probability, like giving that just or certified probability, like giving that just for the correct for actually like the company, how many are predicted correctly. The specificity basically is the true negative over the true negative and the false positive. So the specificity basically we are looking at the people that didn't leave the company, and how many we predicted correctly. So we are looking at this one. Like actually, like the total people that didn't leave the company is 40. How many of them I predict correctly? Which is, it is the specificity 35 over 35 plus 5. Okay. So this is the specificity. The precision represents the true positive over the true positive and the false positive. So the precision here usually, like when you hear the word precision, is related to the model itself. So you don't care about the actual, but you care about your model. So you're going to look at your model. Your model predicted 40 or 45 that they actually left, and predict 4 that they're going to leave. So your model predicted in total 50 they're going to leave, right? How many of them was correct? So in the specific and the precision, which mainly here you look at your model, you look at that, okay, your model predicted actually 50 gonna leave. How many of them are correct? So you're gonna understand like your model, how much is, I mean, your model is accurate. So here in this case, your model predicts is like 45 over 45 plus 50, which would be almost 90% from your model prediction was correct. Okay, so we have here different measures that impact or that can be used to understand how your model behaves. Because at the end, I mean, you don't want a model, for example, like okay, have good accuracy, but your model are biased toward like the yes or no. Like, for example, if I told you, let me give you this example. So if I told you, always your model okay, if I told you here, this one is, for example, extremely large value, 20. So here in this case, and here is 0. In this case, what's the accuracy? It's the same, 80%. But here you're gonna see, if your model predict yes, it's like, it's kind of predict whatever your model predicted yes, they're gonna leave, it's actually they're gonna leaving. But whatever your model predict, like, no, they're not gonna leave. Actually, almost half of them, they are leaving, right? So here in this case, you have an issue with the like your model is not balanced here, basically. So I mean, you have issue with the training of the model, or if it was the opposite, for example, like if you predicted that they're gonna leave and whatever here, 20. So what's the precision of your model? So your model predict 45 and 20, 65 they're gonna leave, but actually just 45. So your model have like a huge like predictions. And so you want the error as well, type 1 and type 2 errors to be honest. All right, so that's basically the major things that I would like to cover as generally how you can deal with the missing values, outliers, just assessing the errors, understanding the difference between predictive and descriptive models, All right. Here, the remaining topic, I'll cover it as well, which is related to mainly how you can um, uh, compare different models for classification based on our ROC values. But meanwhile, all right. All right. So let me finish these, and then after that, we can move into Tableau. We will start just looking into um, the basic analytics with Tableau. So here mainly I'll cover just how we can compare different classification models using ROC, and then I'm going to talk slightly about the clustering as a way for descriptive data analytics. So ROC models basically refer to server operation characteristics curve. We mainly use it. For comparing the performance of different classification models, like which classification models work better for us in case if we have multiple models. And the main parameters we consider for ROC is the true positive rate and false positive rate. I'm not going to go in details with these. So mainly this you need to learn it in the data mining probably course and course related to the build the model. I'll just go fastly through it. So whenever, for example, if you build a classification model in this course, just make sure to use the ROC to compare these different models. So basically, in a simple way, we are saying here, these models usually we draw it between the true positive and the false positive rate, which is the true positive over the true positive plus the false negative, which is the sensitivity rate, and the false positive with the over the false positive and the true negative, which is the specificity. So we draw with sensitivity with 1 minus specificity, and we draw these curve at different thresholds. What does this different threshold means? Yeah, let's focus here. So basically, let's go to this example. Yes. So to see here, when for example, when the model predicts for me a probability, like for example, 70% most likely yes, you're gonna leave. So, or 40% here, should I consider 50% as the threshold? Whatever more than 50% is yes, whatever less than 50% is no, or should I calibrate this value? So this is what we do in the ROC curve, mainly. All right. So we're trying to look at different thresholds and look into the impact that on the model, and so we can compare different models. So here, for example, we have the ROC curve for different models. Like one of the models, a random model, and two other models. So the higher the area under the curve of the ROC, that's mean the higher the curve itself would be the best model, right? Or the larger the area under the ROC curve would be the best model. So in this case, if we have three different models, so the best one is would be the higher the area. So here we are saying the area under the curve, which is AUC here, represent the probability that randomly chosen whatever customer gets higher score that randomly chosen non-customer. So in a simple way, we are saying here, as much as we maximize the area under the curve, this means here our selection are better than being a random selection, or better than random selection. So in a simple way, we are saying here the perfect model would look like this, so where the area is maximized, right? However, our model is here. So if we build different models, and different models have higher area under the curve for the ROC, that's mean the better the model we would have. Okay, I mean, you want to reach the perfect model, but that would be impossible given the stochasticity of the data that you have, right? So this is just simply if you build classification models, that just make sure to compare these models using the ROC values, right? Okay. Okay. So let's see here. So here is just an example of the AOC ranges. If you build different models, so I mean, for credit scoring, for the fraud detection, so you can have a models between 70 to 80%, 85%, or 70 to 90%. The higher the area, the better that you are reaching to the accurate or the most accurate model. But we can see here for credit card scoring, even if you build different models, the best that has been reached usually within a range between 70 to 85%. For fraud detection, it can reach up to 90%.